Alright, you guys, and now for number 12. It's a fairly easy problem with easy points, but there's a lot of key buzzwords that if you don't understand, you're just not gonna get it. Okay? So, context wise, you gotta know this unit well in order to get easy, quick points. Alright? So, we have our homeboy Thurston. Thirsty Thurston believes that more popular musical artists sell more albums, and so he begins to investigate this belief by randomly selecting 8 musical artists and collecting data on the number of followers each of the artists has on a particular social media platform. Blah blah blah. He then collects data on the number of albums each artist sold in the first week after releasing an album, and his data shown on Table 1. Table 1 is right here. Just so that we understand, for example, the guy, for example, artist 4 with 2,300 social media followers, the number of albums he sells in the first week in thousands is 94.9. The guy with 94,400 social media followers sells around 595.5 albums, thousands of albums in the first week. Okay, so that is information it's giving you. And then Thirsty Thurston, decides to calculate the Spearman's rank correlation coefficient. And for this, we need to complete the table of ranks shown in table 2. Now, this is what I mean by understanding buzzwords. A lot of you probably read this and say, all right, I'm going to the next one. Okay? And you realize that it's number 12. There is no next one. And you've been skipping all the problems and you didn't study enough. Just kidding. I hope that doesn't happen to you. Point is, there's two main buzzwords that you might have read that include the word Spearman. So you have Spearman's product moment correlation coefficient, something like that. I don't recall incredibly well how it is. And the other one that we have right here is Spearman's rank correlation coefficient. Now we need to understand the following. They are both for correlation because they both have the word correlation inside of them, okay? It's just the way in which they calculate correlation is a little bit different. Now, first things first, what is correlation? Correlation helps you find a relationship between two variables. So, for example, if you have, I don't know, hours playing League of Legends, and here we have depression. No, just kidding. And we have hours playing League of Legends, and here we have your rank. Okay, the more you play League of Legends, you tend to have a better rank. Okay, and so you might have a bunch of different data points, and you try to find like a line that is like the average of all these points. You're probably gonna end up with a line that looks a little bit like this. Okay, and so this would be correlation, okay? And the R value of this is your correlation, quite literally. And R of 1 is a perfect positive correlation, okay? And an R of -1 is a perfect negative correlation. And an R of 0 is basically no correlation, okay? Because an R of 0 is a flat line, no correlation, no direction, right? If you have it equals to -1, well, it's perfect, but it's negative. See? So that would be the more you play League of Legends, the lower your rank is, which would be my scenario. Okay? Maybe your scenario, because you have quicker reactions, because you're probably a millennial, not a boomer, is gonna be this right here. Okay? Anyways, enough jokes. Back to the world of math. That is correlation. Okay, you try to find the relationship between two variables. If this one increases, how much is the other one prone to increase? Okay, and so usually, especially for Spearman's product moment correlation coefficient, you have a lot of different points, and you're trying to find the value of R that sort of like cuts between all of these, right? For Spearman's rank correlation coefficient, it is very similar, just that instead of plugging in these values here, so this would be for Spearman's product, for Spearman's rank, you want to make sure that all of these numbers are ranked together, okay? And so I have a couple of videos doing Spearman's product moment correlation coefficient, but basically this would be all 1, this would be all 2. You go to stat line reg, and you're gonna get your R value, okay? And for this one, it's actually the same thing. So you can sort of boil it down that the procedure for finding the correlation is always the same. You're going to find, I mean, you're going to write down this is L1, list 1, this is L2, list 2, go to stat, go to line reg, and this is going to give you your R value, okay? The thing is, because we're talking about a rank correlation coefficient, you gotta rank the social media followers, you gotta rank the albums sold in the first week. What do I mean by rank? You have to order them, okay? And so clearly, as you can see here, artist number 8 is number 1. Why would artist number 8 be number 1? Because artist number 8 has the most amount of social media followers. Which one has the next largest amount? Ah, this 49,500, which is why the 49,500 is second in rank. Okay, what is third in rank? It would have to be this guy here, kapow. Fourth in rank, this guy here, yada yada yada. See? So the point is that Spearman's rank correlation coefficient is gonna see, okay, here you have first with first, right? But do you have second with second? Do you have third with third? And that is the correlation that they're trying to find. Okay, that is the cool thing about Spearman's rank correlation coefficient. Anyways, enough blah blah. Let's go piece by piece. And so looking at just the table on the bottom, because that's all we really care about, because we're only trying to fill in these guys here, right? So looking at only the table on the bottom, the one that is in first place clearly is this 595. Which one is the next largest after 595? The 123, okay? So we're gonna go ahead and start circling so that we make sure we already counted it, okay? So the 123 is gonna go here, so that means this one is second in rank, second biggest. Which one's the third one? Probably the 90 something, right? Just gonna double check, yes. So the 90 something is the third one, that is artist 4. Here it is. What's the next one in rank? Probably the 60, it's the 60, so here you would put 4, see? And so you keep going from there, keep filling in. Next biggest would be the 52, so artist 5, right? Boom. And then next biggest would be this guy here, so it's gonna be 6. Next biggest is this one here, 7, and then 8, see? And so notice how, yes, the artist with the most social media also sold the most, but this guy that also had the most social media was 6th place for selling the most. And so, maybe your R value is not going to be perfect. Maybe it's not going to be equals to 1. A perfect one would be if all these numbers matched, but clearly they don't. For example, this third guy ranked 4 in selling, and this fourth guy ranked second in selling. So, something fishy is going on here. Maybe Thurston isn't completely right, or actually, well, he's investigating, but his belief that the more popular the music artist is for selling more albums, maybe it's not necessarily true. Okay, and this is just by looking at the data, looking at the rankings. Okay, so that was a little bit of blah blah for us to understand why people do this in the first place. But going back to the procedure you're gonna memorize because you have your test tomorrow. Okay, you put L1, you put L2, you go to stat line reg. Okay, these are your 3 steps. First, line 1, list 1, list 2, stat line reg, write down the R value. Okay, so you're gonna go to, oops, so you're gonna go to the list, right? So to find list, you go to stat, okay, this stat button, and then you go edit, okay? And so from here you have list 1, list 2. You're gonna erase whatever is there from before. So a quick way to erase is that you go to L1, press clear, enter. Over here the same thing, you go up, press clear, then enter, boom. So now you can go plug it in, right? So let's remember this one is gonna be L1, this one's gonna be L2. So for L1 you're gonna put 4, 3, 6, 5, 7, 2, 8, 1. And for the next one, you're going to have 2, 4, 8, 3, 5, 6, 7, 1. And so as you can see, for example, this one goes with this one. It makes sense. This 8 goes with that 7, which makes sense. This 2 goes with that 6, which makes sense. All right, you want to make sure that from that angle, it all makes sense, okay? So once you do that, well, I told you go to stat line reg, okay? Stat line reg, I need you to associate it to R value. Okay, stat line reg is for an R value, in this case for the correlation coefficient. All right, so you're gonna go to stat, calculate, and reach line reg. It's a regression, okay, line reg. All right, cool. So line reg, your X list is gonna be L1, perfect. Your Y list is gonna be L2, perfect. Your frequency list Do you have one? You don't. So you're going to leave it empty, all right? A lot of people feel like you have to plug something into all of these things. Not necessarily. If your calculator lets you scroll down, then you don't have to plug in something, okay? And in this case, there is no frequency list, so you're not going to put anything, you skip it. For store reg EQ, for our interests, you're pretty much never going to do it. But if you ever want to graph, like this green line that I'm putting here, if you ever want to graph it, at this step, you can press alpha trace and put it into your y equals, okay? So into your y equals, it will go into y1 or into your y5, whatever you want, okay? We don't really care about that, so we're just going to do line reg normally and press calculate. And so from here, boom, you have your R value. Now, I'm sure some of you are thinking, dude, what the hell? Like, my calculator doesn't show my R value. Like, this guy's cheating, dude. Like, his emulator's like hacked or something. Like, what the heck? Nuh-uh. Your calculator is always going to do what it asks it to be done. All right? It's a robot. And as long as artificial intelligence doesn't take over us, this calculator will do as we say. And so if you are not getting an R value, that means that you need to go to mode. So you press mode, and we're very used to having to change radian to degree or degree to radian for using sine or cosine or tangent, all right? But another thing that maybe doesn't get spoken about enough is that down here, you have this thing called stat diagnostics, okay? If it's off, you probably had this happen to you. No R value. And if it's on, you're going to see that now you do get an R value. And so there is no reason to have this on off. Might as well always leave it on. If you ever reset your calculator, make sure you turn it on. There is your R value. Okay, so for part B, which, oh, I don't think I ever mentioned it, but for part B, that you need to calculate the value of Spearman's rank correlation coefficient. And there it is. So R is going to be 0.595238. 238. And if you count significant figures, you're going to count 1, 2, 3. Do you round it up or keep it the same? You keep it the same. So if you want to do significant figures, it's 0.595. All right. So pretty easy 2 points. I don't think it's that hard. And this procedure is something you can memorize. Okay? So that is nice. Anyways, we keep going. We have that Thirsty Thurston believes that artists with a higher number of social media followers sell more albums in the first week. And so he carries out a hypothesis test using a 10% significance level with the following null hypothesis. In the population, there is no monotonic relationship between the number of social media followers and the number of albums sold in the first week. And now we need to write down Thurston's alternative hypotheses. Now, a quick rule of thumb I can share with you right away is that HO is the not version of what you are trying to find. Okay? And H1 is the not, which is the same as just positive, usually, okay, of what you're trying to find. Now let's remember, what is Thirsty Thurston trying to find? Thirsty Thurston believes that more popular musical artists sell more albums. And so what is the not of this? The not of this is that more popular musical artists don't necessarily sell more albums, okay? And that is why they say no monotonic relationship, which is just a very fancy way to say that there is no relationship, okay? So for HO, technically you would say no relationship between number social media followers and number albums sold in the first week, right? And because I told you that H1 is the not version of what you're doing, or just the opposite of HO, you can say that there is a relationship between number of social media followers and number of albums sold in the first week. Now, let's remember that Thirsty Thurston told us that he believes that more popular means more albums. And so to be very rigorous here, you would say that there is a positive relationship between number of social media followers and number of albums sold in the first week. So this is maybe a more intuitive way to explain it. HO is going to be the not version of what you're trying to find, and H1 is going to be the opposite of that. But if I get a little bit more hardcore mathematical with you, because you're in the IB, face it, you gotta get at least a little bit hardcore, all right? Technically, the HO, or the null hypothesis, okay, is something that is always going to state no change slash no relationship, all right? The HO is always going to be like, nuh-uh, there's no effect, all right? The null hypothesis always assumes the status quo, that nothing is happening, okay? While the H1 says, uh-huh, the alternative hypothesis is saying, uh-huh, there is a change, girl, all right? Or there is a relationship. It's not just a fling. Oh my god. Okay, sorry. I'm just trying to be funny. So, for H1, there is a change. There is a relationship. It's not just a situationship. All right. And so for H1, like there is a relationship. There is something happening. Okay. H0 is always gonna be there is nothing happening. H1 is there is something happening. The hard part is to understand, is it a positive something happening or a negative something happening? And because Thirsty Thurston initially said more popular means more albums, you have to put the keyword positive. Okay? And so HO is no relationship, H1 is that there is a positive relationship. Okay? That is for part C. Not that hard, it's just understanding the intuition between HO and H1. All right? Then they tell you that the critical value of RS for this test is 0.643, and to state the conclusion of the hypothesis of the test, giving a reason. Now, part D, sorry, is actually very easy, but you need to understand what is going on, okay? Because on the one hand, I can just tell you, okay, so you got 0.595 from part B for your R value. This is less than 0.643, and so that means that there is, there is insufficient evidence to reject HO. And so I can tell you this, I'm going to tell you to memorize it, and you're going to get those 2 points for free, okay? But we need to understand a little bit better like what is happening, okay? And so you can cut the video off here and say, okay, I can memorize this, nobody cares. Or you can say, I care a little bit, I want to understand a little bit what's going on, here I go, okay? So on the one hand, you got a value for RS, okay? We got a value for RS that was R equals 0.595, all right? And they tell you that the critical value of RS is 0.643. Now, some of you might be thinking, where did this critical value come from? And your critical value is always going to come from the 10% significance level, okay? And so this is a whole test that happened behind the scenes. I'm not sure if it was chi-squared or t-test, probably chi-squared. But anyways, there's this whole sort of process that depending on your significance level, you have a certain critical value. And why do they call it a critical value? Because if you are above this critical value, then you reject HO. If you are not above this critical value, then you fail to reject HO. What is another way to look at it? If you are above this critical value, then there is a change, okay? And if you're below this critical value, then there is no change. So think about it this way. They tell you that the critical value of RS for this test is 0.643. So that means for the correlation, they are asking for a correlation that is at least of an R of 0.643. And so because we got an R that was a little bit below that, around here, they're going to say, I get it. It's a positive correlation, but it's weak. It's not strong enough. And you say, okay, what is strong enough? Strong enough is 0.643. Strong enough is my critical value. So if you have an R value that is stronger than your critical value, stronger than this sort of minimum that they're asking for, then yeah, you would say, okay, there's valid evidence that Thirsty Thurston was correct. But in this case, Thirsty Thurston was incorrect because the R value he got was below the critical value, okay? And this critical value can change depending on the significance level that is asked for, okay? So in this case, we had to relate the actual value we got to the critical value. In other scenarios, you gotta compare the p-value to the significance level, okay? But in this case, we don't do that because we get the actual values, okay? Think about the significant level and the p-value as sort of like probabilities or percents and stuff like that. And in this case, you're literally just comparing values, okay? Like You're comparing the value, the critical value of RS to the value of RS that you got. And so because 0.595 is lower than the correlation that they were asking for, you say, okay, my evidence is not strong enough, so there is insufficient, I don't know why I put insufficient, there is insufficient evidence to reject HO, which another way to think about it is that you accept HO. And let's remember that HO was no relationship slash no change. And so that means that you accept that there is no relationship between amount of media followers to albums that are sold. So Thirsty Thurston, unfortunately, better dedicate himself to drinking water because this guy got it wrong over here. Just kidding. Just because you get something wrong doesn't mean you should give up. True failure comes by giving up. That is my honest opinion. In most cases, I would say. Anyways, part D is that. As long as you state this and then give a little bit of a line saying insufficient evidence to reject HO, you're going to get full credit. Ladies and gentlemen, that is for part D and for the whole test for number 12, actually. So I hope it helped. And yeah, I'll see you around.